Hello everyone, my name is Abdeslam Houari and I am a software engineer in the second year of doctoral studies at Ibn Tufayl University. I would like to take this opportunity to thank the chairs and the conference for accepting my work, which is around the theme of data storage in the cloud for VANET vehicles, entitled using a new Fuzzy MADM method to improve the number of vertical handovers in the case of wireless technology selection for VANET networks, which will be presented by myself under the supervision of Professor Tomader Mazri. We will start with a short presentation of what VANET network is. Then we will see the different challenges facing this type of network. We will talk about the technology selection using MADM approach in the case of VANET network, and we will see afterwards the results of the simulation of the new TOPSIS method for the choice of the technologies, and we conclude by a conclusion. VANET network is considered as a promising project related to ITS. VANET is a form of MANET network where nodes are vehicles. The main purpose is to allow vehicles belonging to the network to communicate with each other in order to be aware of the road condition and consequently reduce considerably the number of road accidents and traffic jams. Vehicles can either communicate with each other in V2V mode using devices called OBU or in V2A mode called infrastructure mode, in which vehicles communicate with RSUs installed at the roadside in order to benefit from several services such as internet access. Autonomous vehicles has several interfaces and sensors that enable it to better understand its environment so that it can make the right decisions at the right moment. So the vehicle begins by collecting information from its surrounding via the sensors and camera on board. Next comes the data storage operation, which with the computing power is the most coveted resources. The following step is devoted to data processing, which consists of selecting only the most relevant data. Lastly, the process ends with the transmission phase that enables the shares of their collected information with other vehicles in the network or other types of networks. VANET distinguishes itself from other MANET networks by its high mobility. The different nodes of this network are constantly moving. The frequent disconnection, the link between the two different vehicles can easily be broken, resulting in the loss of some exchanged data. The other characteristic, dynamic topology. This peculiarity comes from the fact that vehicles drive at high speed, and they can also drive in both directions and can leave or join the network at any moment in a short time. As is the case with other types of network, the VANET networks faces several challenges. The most critical ones are security and privacy, since messages are exchanged between vehicles in broadcast mode, and anyone can intercept them, making the network vulnerable to various attacks that threaten the safety of passengers and drivers. So, in the context of the heterogeneous environments, there are several types of MADM method. So, TOPSIS HP and VCore that have proved their efficiency in solving VHO decisions, mainly for the simplicity of their implementations. Different studies have employed the HP TOPSIS pair for decision-making situation. HP to calculate the vector weight and TOPSIS for ranking access network. and the results showed the importance of the weights in decision making. In this study, we tried to overcome the weakness of the TOPSIS method for application fields characterized by high mobility, as it's the case for VANET network. One of the major concerns faced by this method is the reversal phenomenon, which occurs at the preference order level due to the addition or removal of an alternative from the original decision problem. Several attempts have been made by the authors to improve the TOPSIS method, but no concrete solution is implemented yet. The method we propose, TOPSIS et al., is an improvement of the fuzzy TOPSIS method, based on the vertical handover decision by combining it with the fuzzy AHP generated new criteria weights. The study focused on the proposal of a new MADM method to evaluate the two alternatives subjects to this paper, 5G and the CRC. To do so, we started by identifying the alternatives and the evaluation criteria, and then we build the hierarchy of decisions. The criteria retained to carry out the handover decision are those of capacity, security, coverage, reliability, and latency. Finally, TOPSIS and TOPSIS et al. Are applied to the weighted matrices to obtain the ranking of the two technologies. 1,000 iterations covering the different weight vectors have been performed. The simulations performed for both 5G and the CRC wireless technology involved the 4 QoS class type that cover the different user-side requirements. The generation of the values of each of the criteria were randomly produced based on the ranges specified in the following tables. So the simulation was performed on 1,000 vertical handover decision cases using a Java program designed for this purpose. First, we constructed our pairwise comparison matrix using the linguistic variable listed in the table 2 membership function of linguistic scale. Then we applied the FHM method to generate the weights per criteria. Next, we apply our AHP method again to determine the importance of BW relative to the ideal solution and the anti-ideal solution, respectively. Finally, we apply the enhanced TOPSIS method, TOPSIS et al., to measure the new closeness to the ideal solution and rank our alternatives for the 4 classes of QoS. The results of the comparison presented in this paper show that the improved TOPSIS method is more efficient than the conventional TOPSIS method for wireless technology selection in heterogeneous and topologically dynamic environments. In the first simulation, we evaluate the proposed approach in comparison with the classical method. In the second simulation, compares the average numbers of VH by methods. The following figures shows that the applied method reduces considerably the number of VH for the 4 QoS classes, allowing in consequence to overcome the deficiencies of the classical method. To conclude, this paper proposes a new approach to improve the selection of wireless technologies and VANET network by improving the standard fuzzy TOPSIS alternative selection method to fit the VANET context. Our approach uses the fuzzy AHP method to measure the relative weights of the selection criteria. The simulation where we performed shows that the proposed method improves significantly the number of vertical handovers compared to the classical method. And thank you.